All right, so we start off Unit 5 with some review of what you've done in the past. Some stuff from grade 9, some stuff from grade 10. So we go back and we take a look at Pythagorean theorem from grade 9. And I think we're all familiar with it. C squared equals a squared plus b squared, or a squared plus b squared equals c squared. It doesn't matter the order that you put them in. And Pythagorean theorem is specifically used with right angle triangles when you're given two side lengths and you're trying to find the third side. So the only thing that's extremely critical about Pythagorean theorem is that the C represents the hypotenuse, which is the side opposite the right angle, and it's the longest side of the triangle. The A and the B, it doesn't matter which one you put in for A and B because, of course, you're just adding them together anyway. But C must always be the hypotenuse. So taking a look at a couple of examples here, just very, very quickly as a refresher of Pythagorean theorem. We go across from the right angle, and that's the hypotenuse. So C squared equals a squared plus b squared. Again, it doesn't matter what you put in for A or B. I'll put 5 in for A, 12 in for B. So 25 plus 144. And of course, our last step to solve for C is take the square root of 169, and we get 13 centimeters. Okay, typical, straightforward Pythagorean theorem type question. Same thing with our second example. Go directly opposite the right angle. That's the C, or the hypotenuse. C squared equals a squared plus b squared. I'm going to put the 3 in for C. So 3 squared equals, I'll put the 1 in for A. And then of course plus b squared. So I have 9 equals 1 plus b squared. I need to bring that 1 over the equal sign, subtracted from 9. So 9 minus 1. And we take the square root. And the question does tell us to give exact answers. So because it's looking for an exact value, I'm going to leave it as root 8. Okay, as soon as I take the square root and I get a decimal, it's no longer exact, of course. So I leave it as root 8. Now, one thing that we remember back from Unit 3 is that root 8 can be simplified, right? We can get that in the lowest terms. So if you remember root 8, that can be broken down into root 4 times root 2. Square root of 4 is 2. So B, in fact, equals 2 root 2 centimeters. And we stick our units in there. We want to simplify a radical wherever possible, just like a fraction. You always want to simplify it, get into the lowest terms. Same thing with radicals. You want to simplify them and get them into reduced form. So that was grade 9. Moving on to grade 10. We started looking at primary trig ratios and the famous SOHCAHTOA. So the side opposite the right angle, we've already talked about, that's the hypotenuse. And then the question will always either give you an angle or ask you to find an angle. Either way, inside of the triangle, there will be another angle besides the right angle. And the side opposite to that is the opposite, because opposite the angle. The third side is the adjacent. And the reason why it's called the adjacent is because adjacent is a fancy word that just means next to. Okay, we don't say that my neighbor is adjacent to my house. We say they're next door to my house. Well, adjacent just means the side next to the angle, which is not the hypotenuse. So we have our 3 primary trig ratios, sine, cos, and tan, which gives us SOHCAHTOA, right? Sine is opposite over hypotenuse, cos adjacent over hypotenuse, and tan opposite over adjacent. So our 3 trig ratios are sine, cosine, and tangent. And those are trig ratios based on the ratios of the two sides. So for sine, the short form is just sin. So sine of the angle is equal to the opposite over hypotenuse. Cosine, short form is cos of the angle, adjacent over hypotenuse. And finally, tangent, short form tan, which is the opposite over the adjacent. And they're referred to as the primary trig ratios because primary just means, of course, the initial, right? The first ones. So sine, cos, and tan are the primary trig ratios. We'll continue on looking at some examples, reviewing how to solve for sides and or for angles. So the first example here we're going to look at is finding a side length. And the first thing that I would recommend, and it doesn't take very long, is to label the sides. Right angle, side opposite that is the hypotenuse. The angle given to me in the question, opposite that is the opposite, and the third side, of course, is the adjacent. I would go ahead and I would label it just like that, hypotenuse first, then the opposite, then the adjacent. The reason why I like labeling the sides is because now when I look at this, I see that there's one side where there is nothing there. There's no information given to me. This adjacent side, I don't have a letter, I don't have a number. This side is completely left blank. That helps me determine which of the primary trig ratios I need to use, sine, cos, or tan. Because there's nothing here, I can't use the A. I have nothing to put in for A. So if I can't use A, I can't use cos, because cos is adjacent over hypotenuse, and I can't use tan, because tan is opposite over adjacent. So the only trig ratio I can use through process of elimination is sine. So we'll do sine of 40 degrees equals the opposite side, which is x, over the hypotenuse, which is 19. We're going to cross multiply, right? If you want, we can kind of put this over 1, cross multiply them. So x equals sine 40 times 19. And we'll put that into our calculator exactly as we see it. Now, one thing with calculators is when it comes to trig, I'll zoom in here, is that you want to make sure that your calculator is in degrees. You want a DEG or a D in your display. You definitely do not want radians, so you don't want RAD or R, and you don't want gradians either. You want to make sure that's in degrees. So look for that DEG, because if it's in radians, you will still get decimals, you will still get an angle, but they'll all be completely wrong. So knowing that we're in degrees, we're just going to type in exactly as we see it, sine 40 times 19. And we get 12.2. Now, this question doesn't have units, but of course, if it did, then we put the side length in the units. Okay, moving on to the next example. Same sort of thing. I'm going to label my sides first. There's my right angle. So that's the hypotenuse. 38 degrees, opposite, other side, adjacent. Hypotenuse, where the H is, nothing there. Can't use it. So I can't use sine, and I can't use cos, because those both require a hypotenuse. So in this case, it's going to be tan. So the tan of 38 degrees equals opposite over adjacent. And again, if we want, we can put that over 1 and cross multiply. So x times tan 38 equals 1 times 20, which is 20. I want to get x by itself, so I divide both sides by tan 38. So x equals 20 divided by the tan of 38 degrees. So 20 divided by tan 38, 25.59, and we'll round that to 25.5. 0.6. Two examples of finding side lengths. Now we're going to look at finding angles. So again, I'm going to label my three sides: hypotenuse, opposite, adjacent. Adjacent, nothing there. Nothing there, can't use it. Opposite, hypotenuse, sine. So sine of my angle equals 1.4 over 5.7. So we'll divide those, 1.4 divided by 5.7, and we get this super long decimal. And the thing is, we want to keep all of those digits in that decimal. I don't want to round that to 0.2 or 0.25. I want to keep everything, because the more decimals I have, the more accurate my angle is going to be in my answer. So I now have sine theta equals 0.245614035. It's a decimal. I need to find the angle. So in order to find an angle, I want to take the inverse of this decimal. And the inverse is this sine minus 1. Remember when we did inverses back in Unit 1? It was f, and a little exponent there, minus 1 to indicate inverse. Same thing here with trig. So theta is equal to the sine inverse, that's sine minus 1, of 0.245614035. So I can do that. I can do second function, sine inverse of my answer, 14.2, and we always round to the nearest degree, so 14 degrees. Okay, moving on to the last one. Label my sides: hypotenuse, opposite, adjacent. No H. No H means I can't use sine or cos. I'm using tan. So tan theta, opposite, over adjacent. Now, I don't want to waste my time writing out these big long decimals like I did in the previous example. Waste of time, waste of space. I want to make this quicker. So I'm going to do all of that in one step now. I know I need to take the tan inverse of this decimal that I'm going to have here. So why don't we just write it in one step? Theta equals the tan inverse of 8.7 divided by 12.4. And we can do all of this in one step. There's no writing out of decimals. There's no showing work. It's just from here to our answer. So to get to our answer, I'm going to do tan inverse, bracket, 8.7 divided by 12.4 equals 35 degrees. So rather than doing this, dividing and getting this huge decimal and then doing the sine inverse, we're now just going to do it in one step, right? The tan inverse of whatever that fraction is, and it takes us right to our angle. So we reviewed grade 9, which is Pythagorean theorem. Quick review on grade 10, SOHCAHTOA, which takes us to the last page, which is grade 11. Something a little bit new. So if we look at our reciprocal or our primary trig ratios here, sine, we just talked about that sine is opposite over hypotenuse. Cos, adjacent over hypotenuse. And tan, opposite over adjacent. Okay? Now, if we just take a second, I ask you about reciprocals. We should all know that reciprocals mean you just flip something, right? So if I asked you, if I have 2/3, the reciprocal of 2/3 right, is 3 over 2. We're all familiar with reciprocals, and that all you're doing is just taking something and flipping it. So if I'm looking at reciprocal trig ratios, I'm taking the reciprocal of these, which means I'm basically just flipping the trig ratio. So now sine becomes hypotenuse over opposite. Cos, hypotenuse over adjacent. And tan, of course, adjacent over opposite. Now, it would make a lot of sense if we just call these reciprocals, right? The reciprocal of sine, or the sine reciprocal, or the cos reciprocal, or whatever. But they're called something different. Each of these has their own unique name. So when it comes to sine, the reciprocal of sine is something called cosecant. So it's cos e cant. The reciprocal of cos is secant. And the reciprocal of tan is cotangent. Now, tan, cotan, cotangent, that one makes sense. Sine and cos with cosecant and secant looks a little different. And what I mean by that is if we look at cos, secant, goes with sine. It doesn't go with cos. Cos and cos do not go together. Sine and secant do not go together. So if you think S and S, C and C, then think the opposite, that's kind of how you can remember them. Now these have short forms as well, just like sine, cos, and tan. So cotangent, short form is cot, C-O-T. Secant, short form is S-E-C. And cosecant, short form, is CSC. So it's a matter of remembering cosecant reciprocal of sine, secant reciprocal of cos, cotangent reciprocal of tan. So here's another triangle. I'm going to label my sides. Hypotenuse, opposite, adjacent. And now I'm asked to state the 3 reciprocal ratios. So my 3 reciprocal ratios are cosecant, secant, and I'll go down here for cotangent. So cosecant is the reciprocal of sine. Sine is opposite over hypotenuse. So now I'm looking at hypotenuse over opposite. Hypotenuse 18 over opposite, which is 15. And we can get that in lowest terms, right? Both those are divisible by 3. So we get 6 over 5. Secant, reciprocal of cos. Cos is adjacent over hypotenuse. So now hypotenuse over adjacent. Again, we can divide both those by 2. So we get 9 over 5. Cotangent, reciprocal of tan. Tan is opposite over adjacent. So now adjacent over opposite. And in lowest terms, 2 over 3. So reciprocal trig ratios, cosecant, secant, and cotangent, are just flipped of the primary trig ratios. And just a matter of remembering, cosecant's with sine, secant's with cos, and cotangent is with tan. And we'll finish off with a couple other examples that I just wanted to look at here. Evaluate each of the following. So cos 37 is pretty straightforward. I'm just going to type in cos of 37 degrees. I get my decimal equals 0.798635551. Makes sense. Next, CSC, 73 degrees. That's cosecant. So I'm looking at cosecant of 73. Well, cosecant is reciprocal of sine. So this is actually equal to 1 over sine 73, right? Because that's the reciprocal of sine. So I'm going to do 1 divided by sine 73, and that's my decimal. 1.0457. We'll round that after 4 decimal places. And then cotangent, reciprocal of tan. So 1 over tan of 49. And I do 1 divided by tan 49. And we get 0.8693. Question 2, determine the value of theta to the nearest degree. So again, secant gives me this decimal. Secant is the reciprocal of cos. So again, I want to take the reciprocal of this decimal. So cos theta equals 1 over 2.5688. I divide those, 1 divided by 2.5688, and I get 0.389286.826. And with a decimal, trying to find an angle, I want the cos inverse of that decimal, of 0.389 and so on. And when I do that, my angle is 67 degrees. Tan is a primary trig ratio. So I can do this one. I can do theta equals a tan inverse of 0.877, and my angle is 41 degrees. And for our last one, cosecant, reciprocal is sine. Now again, rather than doing all this decimal writing like we did over here in part A, why don't we just do theta equals sine inverse of 1 over 1.54366. And we do that, sine inverse 1 divided by 1.5466, 40.37. We'll round that to 40 degrees. So for these last basically 2 questions here, when you're looking at reciprocals, right, you put it under 1 and then you evaluate. So if it's an angle, you do 1 over, or the reciprocal of the angle. And if it's a decimal, then just the reciprocal of the decimal. So at the end of this lesson, really what I'm looking for is a good review of SOHCAHTOA, because that's going to come back in this unit. So make sure you know that was really well. And make sure you're aware of cosecant, secant, and cotangent. This lesson is just an introduction to those, and we'll be coming back and visiting those much later in this unit. For homework questions, not a lot. Just review 4, 5A, 6, 7, and 11A.